and welcome to GCSE Chemical Changes with Mrs. Castanera. We're on Lesson 7, Acid Reactions and Neutralisation. So our keywords for this lesson are neutralisation, acid, alkali and base. So to start with, I'd like you to complete the 8 questions in the knowledge check, so pause the video whilst you do that, please. Okay, so let's go through those. Question 1. Metal plus acid turns into salt plus hydrogen. You need both for the mark. The salt formed from hydrochloric acid and iron is iron chloride, or if you've written FeCl2 like this with capital F, capital C, and lowercase e and L with the 2, you can have the mark as well. So just 1 mark available here. Magnesium sulfate is formed from sulfuric acid and magnesium, or alternately you can have the mark for the formula there. Zinc nitrate is formed from nitric acid and zinc. Again, you can have the mark for the formula there. The salt formed from hydrochloric acid and calcium is calcium chloride, or again, if you've written the formula, you can have the mark instead. The substance that's oxidized in question 3, sulfuric acid and magnesium, is the magnesium itself. The substance reduced in question 5 with the hydrochloric acid and the calcium is the hydrogen ions, which are in the aqueous hydrochloric acid solution. And question 8, give 3 uses of sodium chloride. So you can have any 3 of flavouring, food preservation, cleaning, making chlorine gas, medicine, thawing icy roads, and making fertilisers. Any 3 of those. So that's out of 10. So give yourself a mark out of 10 there, please. So in today's lesson, we will be able to explain in terms of gain or loss of electrons that these are redox reactions, and you should know what a redox reaction is. It's when reduction and oxidation occur at the same time in a reaction. We will also be able to identify which species are oxidized and which species are reduced in given chemical equations. Okay, so moving on. Acids, bases and alkalis. So acids are neutralized by a group of substances called bases. The bases that are soluble in water are called alkalis. Okay, so it's the bases that are soluble in water are called alkalis, and those that are insoluble are just called bases. Okay, so soluble alkalis, so bases that are soluble in water, those alkalis, are things like soluble metal hydroxides. Bases that are insoluble, so we don't call them alkalis, we just call them bases, are things such as insoluble metal hydroxides. Okay, so it's the same sort of product, but just some are soluble and some are insoluble. But you can also get metal oxides, which are generally insoluble too. So when they neutralize an acid, so when the base neutralizes an acid, the product is salt and water. Okay, and by metal carbonates to produce salts, waters and carbon dioxides. Okay, so our key important information here is these 3 equations which you need to know. Acid plus alkali turns into salt plus water. Acid plus base turns into salt plus water. Acid plus carbonate turns into salt plus water plus carbon dioxide. So we're going to go around these to indicate that we need to learn them. Okay, so I'm going to write that here. What I want you to do is I want you to pause the video and I want you to try and learn those 3 equations, memorise them, write them out if necessary. Once you've got them learnt, you can come back to the video. Okay, so alkalis. Hopefully you've learnt those 3 now. Alkalis are soluble bases that have a hydroxide ion. Okay, so that's the OH minus ion. When they dissolve in water, the hydroxide ion dissociates and it becomes free in the solution. Okay, remember that pH scale. The more hydroxide ions there are, the greater the number on the scale. Okay, and to make the hydroxide ions appear, you have to dissolve them in water. Okay, so bases. So bases is the general name we give to substances that can neutralize an acid. So insoluble bases are metal hydroxides or metal oxides. both of which produce salt and water. Okay, now there's some videos to watch here. Okay, so they are few school videos, and there are two. What makes things alkali and what makes something acidic? You can find both on YouTube. They're on the Fuse School channel. So if you go to YouTube, you can either click on these links to do that, which is much easier if you've got a digital copy. If you don't, go to YouTube, search Fuse School, what makes things alkali, and watch that video. Then search Fuse School, what makes something acidic, and watch that video. So pause this video whilst you go find those YouTube clips and watch them, please. So you should have watched those videos now and have a much better understanding of neutralisation reactions. So we're moving on to carbonates. So metal carbonates have a carbonate ion, which is CO3 2-, and that's because it is negatively charged by 2, which means it's gained 2 extra electrons. I'm going to write a note to show that. So it's gained those 2 extra electrons. So that carbonate ion is part of their structure, which means that carbon dioxide, CO2, is also produced alongside the standard salt plus water. Now these reactions tend to fizz, which is effervescence, as carbon dioxide is always released as a gas. Okay, so carbon dioxide in these reactions is released as a gas. The positive test for carbon dioxide is that it turns lime water cloudy. Okay, it forms a white precipitate and turns cloudy. The reason it turns cloudy is because it reacts to form this white precipitate. Precipitate means particles suspended in the water. So those precipitate particles that are suspended in the water, they are solid. Okay, so they're small pieces of solid, and eventually over time they will settle to the bottom usually. So there's a video to watch now to learn more about the reactions of metal carbonates. So another Fuse School video on YouTube. So again, search for Fuse School, acid plus metal carbonate is the video you're looking for. If you've got a digital copy of this, click on the link to watch it. So pause this video whilst you go watch that one. Okay, so hopefully you've watched that and now you have a much better understanding of carbonate reactions. So we're going to move on to neutralisation now. So neutralisation is when acids react with bases and the hydrogen ions and the hydroxide ions react to form water. And that can be shown in this equation here. Okay, this is very important and you need to learn this. Okay, so that leaves no concentration of hydroxide or hydrogen ions, okay, it's because it's all formed water, okay, so therefore this solution is neutral, okay, and a neutral solution has pH 7. And that is a green colour on the pH scale. And there's a video to learn more about neutralisation. And it's a Fuse School video on YouTube. You can click the link or you can look it up. Fuse School Neutralisation of Alkalis. So pause this video whilst you watch that, please. Okay, so hopefully you have a better understanding about how neutralisation works now. So looking at how we identify neutralisation, so remembering that there is universal indicator, and that's a mixture of various dyes, okay, so different dyes in it, and they change colour depending on the pH, okay, so different colours on the pH scale. We've done this before. Neutral, as I said a minute ago, is green in colour. Acids tend to be reds and oranges, and alkalis tend to be blues and purples. Okay, so when we get our sample of solution and we mix it with the universal indicator, we get that colour change. Now, normally we would do an investigation into this, but obviously that's practical and we can't do that at the moment because that's something we need to do in the classroom. So here we have an example of a practical where we mix hydrochloric acid with sodium hydroxide. Okay, now we aren't able to observe that. However, knowing that sodium hydroxide is our alkali, we can write that in here, Knowing the symbols and the formula for hydrochloric acid here and the rules that it forms a salt plus water, you can complete this section of the equation for that. So what I'd like to do is pause the video and complete the equation to show what happens when hydrochloric acid reacts with an alkali, which is sodium hydroxide, and the specific salt and water that's formed. So pause the video now. Okay, so let's go through that. So hydrochloric acid, the symbol for that is capital H, capital C, lowercase l, so the hydrogen and the chlorine. So if you've got that right, give it a tick. We've written sodium hydroxide in here because that's our alkali. Then that forms a salt, which is the sodium chloride, taking the chloride ion from here, and that's NaCl. And then water is what we write here, and it's H2O. So there are 6 marks here, so give yourself a mark out of 6, please. So the next practical example that, again, we're not going to do, but we're going to have a go at the equation for, is an acid plus a base. And our acid is sulfuric acid, and our base is copper oxide. Okay, so we'll be mixing our sulfuric acid with copper oxide to form a salt plus water. I'd like you to fill in these blank spaces, please, and pause the video whilst you do that. Okay, so let's go through that. So sulfuric acid is H2SO4, all those letters are capitalised. Copper oxide is the base. Copper sulfate is the salt, which is CuSO4. And the U is lowercase, the other letters are capitalised. Obviously it's water here, which is H2O. So that's out of 6, so give yourself a mark out of 6, please. So the next experiment we would typically do is an example of an acid plus a carbonate. This time our acid is hydrochloric acid and our carbonate is calcium carbonate. Okay, so what I want you to do is, again, fill in the answers, the words that are missing from our equation, and this time if you are able to predict what you might observe or any observations you might see. Okay, so pause the video whilst you do that. Okay, so let's go through that. So hydrochloric acid, capital H, capital C, lowercase l, there's actually 2 of those required to balance the equation. So if you've written a 2 there, well done, you get an extra mark. Calcium carbonate is the name of the base. Calcium chloride is the name of the salt that's produced, and that's CaCl2, capital C's, lowercase a, lowercase l. The name is water for water, which is capital H, lowercase 2, capital O. And carbon dioxide for this name, and CO2, both letters are capitalised. So that's a mark out of 7 for this part. But there is also, I asked you to tell me if you could see anything or there's any observations you would make. I would expect that hopefully you've said it would be fizzing or effervescence because of the carbon dioxide released as gas. Now you don't need to write this part. The only part you need for the mark is either the phrase fizzing or effervescence. You might have also said that it turns green because it's neutral, pH 7. Again, if you've written about it turning green, you can have an extra mark as well. So in fact, that takes us up to 9 our marks now. So give yourself a mark out of 9 for this one. So moving on to the knowledge check on page 50, I'd like you to complete all 8 questions, please, and pause the video whilst you do this. Okay, so let's go through those. Question 1, metal plus acid turns into salt plus hydrogen. You need both for the mark. The salt formed from hydrochloric acid and iron is iron chloride, or FeCl2. You can have the mark whichever way you've written it. Magnesium sulfate is the product of sulfuric acid and magnesium. Again, if you've written it as MgSO4, you can have the mark as well. Zinc nitrate is formed from nitric acid and zinc. And again, if you've written ZnNO3 you can have the mark instead. Calcium chloride is formed from hydrochloric acid and calcium. Again, if you've written it as CaCl2, you can have the mark. The substance that's oxidized in question 3 from sulfuric acid and magnesium is the magnesium. The substance reduced in question 5 from the hydrochloric acid and the calcium is the hydrogen ions from the aqueous or dissolved hydrochloric acid. 3 uses of sodium chloride, you can have any 3 from flavouring, food preservation, cleaning, making chlorine gas, medicine, thawing icy roads, and making fertilisers. You can have up to 3 marks for this question. So give yourself a mark out of 10 for this, please. And then we'll move on to the application of knowledge question. So the application of knowledge question asks that a chemical manufacturer wanted to make some copper sulfates. So I'm going to highlight this because it's what they want to produce and it's important to us. Suggest the reactants for this reaction and predict the products. So you're going to need to write an equation, ideally, to show the reactants and products to make copper sulfates. I recommend writing it as a word equation and then following up with the same equation in symbols. If you want to add state symbols, that would be an excellent idea and it would improve your grade on this. So pause the video whilst you do that. Okay, so let's go through that. So we have sulfuric acid plus copper oxide turns into copper sulfate plus water. The symbols for the sulfuric acid is H2SO4, and that is aqueous, which means it's dissolved in water. The copper oxide is CuO, the U should be lowercase, the C and O capitalised, and that is a solid. The copper sulfate is CuSO4, the CSO are capital and the U is lowercase, and that is aqueous, dissolved in water. And that also produces water, H2O, and that is a liquid because water can't be dissolved in itself, so it must be a liquid. So there are quite a lot of ticks here. There are 12 marks available here. Now, if this were an exam, it wouldn't be out of 12. This would probably be out of maybe 3. You'd have maybe a mark for each section, or it might be that you have to get some marks for the products and some marks for the reactants, and maybe 1 mark for getting all the state symbols correct. Okay, but for now, we're going to do this out of 12 to show you how well you're doing with that. Okay, so one last thing before we finish. So here we have the keywords. There are 4 of them: neutralisation, acid, alkali and base. You need to learn each of these keywords with their definition, okay, and you need to be able to give a pretty good definition for each of these. Close to, it doesn't have to be exactly the same as, but close to the definitions here. So make sure you learn these, please. Once you've learnt them, that's the end of the lesson. If you have any questions, please email your teacher or myself. We'll be very happy to help you. Thank you very much.